the snake, an instinctive killer. It waits silently, then strikes with lightning speed and without mercy. Another victim pays a painful and deadly consequence. Living in the woods, marshes, and fields, snakes are a vital link in nature's design. At work, electricity is an equally vital link on today's production line. It can be just as quick to strike and just as deadly as a snake, unless you properly control it. This program covers the Occupational Safety and Health Administration, OSHA, rule for safe electrical work practices. You'll learn about physical safeguards and barriers, how housekeeping contributes to your safe environment, and procedures like lockout-tagout to de-energize lines. Finally, you'll learn how to safely get a shock victim away from an energized circuit and about first aid. If you've worked around electricity, you know that materials with low resistance are called conductors and used for wires, switches, and electrical connections. Copper has almost no resistance to electrical current flow, so many wires have copper cores. Other metals, such as aluminum and liquids like mercury and water, are also good conductors. Since your body is made up of water, chemicals, and minerals, you're an excellent conductor when the snake strikes. Add hazards such as metal jewelry, a wet floor, or broken tools, and you're really encouraging the electrocution. If current passes through your body from arm to arm, it can fatally damage your heart and other vital organs. No one wants you to be shocked. That's why there are levels of protection designed to let you work safely around electricity.
There are various techniques used for handling venomous snakes, and they range from the unnecessarily hazardous and cavalier to the kinds of appropriate techniques that professional biologists use to handle them. In our case, we use leg protection, either hard leg protectors or thick chaps, and we have hooks and tongs that we can use to manipulate the animals at a safe distance.
Electrical maintenance equipment is also designed for safety, and yet electrocution is the second leading cause of death among workers in general industry. So, whenever possible, your employer provides engineering controls to eliminate shock hazards. Insulation is one such engineering control. A material with little or no conductive properties is used to put a barrier between you and flowing current. Glass, rubber, mica, and some plastics make good insulators. As long as the insulation remains intact, you're protected. Likewise, junction boxes must be without holes in their covers to protect you from contacting live wires or parts. Unfortunately, let a little weather, hard use, or age affect these engineering controls, and the threat of strike returns. That's why the second level of protection is safe work practices, and why you'll be trained to use them. Before each shift, inspect your tools and work areas for electrical hazards. Manufacturers install insulated grips on electrical tools, but that insulation must be free from cracks, tears, and worn spots. Homemade insulation can expose you to the snake's bite. Power tools must meet national code requirements, so check their double insulated casings and third wire power cord grounding to be sure they work right. Check to see that safety guards or shields are in place. Switches have secure terminals, and cords are not frayed or cut. If you must use an extension cord, be sure it is rated for the tool you're using and the environment in which you're working. It must be a 3-wire cord and have a ground fault circuit interrupter. The GFCI can be of a circuit breaker type, portable type, receptacle, or built into the extension cord. As the name implies, the GFCI interrupts the circuit when there is as much as 5 milliamp or 5/1000ths of current difference between the hot or outgoing wire and the neutral or return wire. The GFCI is not a circuit breaker. It is a current monitor and reacts faster than the snake to prevent electrical shock to you. Unsafe portable electric extension cords are common causes of electrical shock. That's why it's important to be sure the one you use on the job is rated for the job. Before your shift begins, inspect any portable extension cord you might use for loose parts, deformed and missing pins, or damage to its outer jacket or insulation. Be sure its plug and the receptacle are designed to be used together. Safe outlets are grounded and should never be overloaded. More than 2 plugs per double outlet is overloaded. A qualified snake handler maintains the tools of his trade so that they perform properly when needed. Switches, components, and wiring won't stand up to rough handling. Raising or lowering equipment by its flexible cord or stapling a cord damages insulation. In the wild, the snake counts on the element of surprise to strike successfully. At work, there are warnings to alert you to the snake lying in wait. Read and follow safety signs, symbols, and barriers put there for your safety. Stop bars and emergency cutoff switches are usually red. Orange sometimes marks dangerous exposed machine parts or electrical hazards, and yellow calls for caution. Green shows where to find safety items, such as a first aid kit, barricades, and emergency eye wash. Even the atmosphere can be dangerous around electricity. Air full of dust, flammable fumes, or excess oxygen can be ignited by a stray spark. Humidity helps to reduce static electricity, which can also create a spark and explosion if the air is full of dust or flammable vapors. Ventilation is one way to lower the concentration of atmospheric hazards in your work area. And light. If you can't see well enough to work safely, set up approved portable lighting. If there's not enough light to help avoid a shock, you should not enter an area where there is an electrical hazard. Housekeeping is another safe work practice to help you avoid electrical shock. Keep your tools clean and arranged conveniently. A little oily film or carbon deposit can conduct electrical current. Drop a tool across a conductor and you'll feel the bite. For the same reason, spills should be cleaned up immediately. A wet floor provides an especially dangerous work site. Any type of moisture, including wet clothes and tools, can increase conductivity and provide a better path for current to flow to your heart. Even sweat helps to conduct electricity, so keep a towel or rag handy. And if it starts to rain, head for cover. Never work with electricity when exposed to wet weather. If you must work in a moist environment, locking connectors with proper hoods, such as marine devices, provide additional safety. Periodically, check all other on-the-job equipment for safety and good repair. If you need a ladder, use only sturdy wooden or fiberglass. Aluminum conducts electricity. Rubber feet or end caps give added protection since they are non-conductive and won't skid. Work experience has shown that lockout-tagout can save your life. Before working on circuits and equipment, follow your facility's procedure to the letter. To be safe, a lock and tag are always placed on each disconnecting means, such as a switch or circuit breaker, which could energize the line. In some facilities, tagging alone is permitted if it is demonstrated that tagging provides the same measure of safety as locking and tagging. In that case, additional safety measures must be taken, such as removing fuses, opening an extra disconnecting means, or blocking control devices. Never remove a lock or tag applied by someone else. If work extends beyond one shift, the off-going shift removes their locks and tags, and the oncoming shift applies their locks and tags before starting to work. Conductors and parts of equipment that have not been locked out or tagged are treated as if they are energized. Even if the equipment is locked out, don't assume freedom from electric shock. It's possible that energy from an additional source can still provide a deadly shock. Check to see that all power sources are controlled. Never try to find out if there's voltage left in a disconnected circuit by touching the equipment. Proper test equipment must be used. Look for capacitors and other forms of stored energy. To discharge capacitors, a grounding wire is connected between the capacitor and a known grounding source. Leaving this grounding wire in place while working on the equipment gives additional safety from electrical shock. You'll want to disconnect or cap any auxiliary power sources, such as secondary electrical, steam, hydraulic, or pneumatic systems. This includes checking that all moving parts have stopped turning, relieving trapped pressure, blanking pipe flanges, and blocking or supporting elevated equipment. Return all controls to the off or neutral position and apply your lock and tag. The snake handler who carefully captures a venomous snake and then accidentally leaves the cage door open may be in for a big surprise. Before going to work, first verify isolation. After you're sure that no people are exposed, operate the energizing switch or other normal operating controls to make certain the equipment will not operate. Next, verify the main disconnect or circuit breaker cannot be moved to the on position. A voltmeter is used to check for voltage. Press all start buttons and other activating controls. Shut off all machine controls. When work is complete, first inspect the entire work area to be sure all tools, jumpers, grounds, and other devices are removed. Then, warn co-workers to stay clear of the equipment being returned to service. Remove locks and tags and energy isolating devices to restore energy. Ensure equipment is safe to operate with all guards installed and blocks, braces, and grounds removed. Count workers to be sure everyone is clear of equipment. Notify everyone affected that the system is being returned to normal operation. Remove locks and re-energize. Statistics show that de-energizing saves lives, but sometimes turning equipment off increases hazards such as interrupting life support systems, deactivating emergency alarm systems, or ventilators. Under these and other circumstances, only qualified persons may work on live equipment. A qualified person is someone familiar with the construction and operation of the equipment to be worked on. That person is specifically trained in the hazards of working on energized parts and equipment.
The primary technique that we use for personal protection is simply to keep ourselves at a safe working distance from the animal. Most venomous snakes can strike very roughly about a third of their body length when they're coiled in a striking position. And so staying out of that kind of range is important, and also giving yourself a good margin of safety beyond that range is also important. That's why the long tools, the hooks, the tongs, are important, and if the animal should move suddenly, that's when the leg protection comes into effect, having something that basically protects you against a bite in the very unlikely event that you should be within range. Sturdy boots also are important in personal safety.
PPE starts with the right clothing. You'll need a good pair of safety shoes with insulated soles and heels, comfortable clothing with buttoned shirt cuffs, and no neckties or scarves. Remove all jewelry, rings, and metal wristwatches. Gold and silver are excellent conductors and can make you part of a live circuit. And a short circuit through jewelry could ruin sensitive electronic circuits as well as kill you. A standard electrician's tool belt is okay, but remember that metal rivets can conduct electricity. In tight spaces, take the tool belt off first. Dangling tools can drop into operating equipment or across electrical connections. Personal protective equipment is designed and made of materials to protect you in many ways. You might say this equipment goes a long way toward keeping the snake at a safe distance by protecting you against an unexpected strike. Non-conductive head protection protects you from electric shock, electrical burns, falling and moving objects. Be sure your hard hat is rated for the electrical hazard you face. Always wear eye protection when performing electrical work, especially on live circuits. A short circuit or a fault could result in not only flash burns, but hot molten metal particles can be thrown into your eyes and your face. A welder would not strike an arc without proper eye protection. If a conductive object, such as a screwdriver, wrench, or fish tape, contacts a live part and then ground, you are in fact welding until an overcurrent device trips the circuit. Do not use your own safety equipment unless it is approved by your employer. As with all your equipment, inspect and test your PPE before use and protect it from damage. One way to protect rubber insulating material is to use an outer leather covering. Although all energized circuits are electrical hazards, none have caused more deaths than overhead power lines. Just like a contained snake is a safe snake, a safe overhead power line is one that has been de-energized and grounded. The rule of thumb is to work from 10 feet to 35 feet away from an energized source. Even experienced qualified people cannot identify line voltage by eye. Accidents can happen, and you need to know what to do to protect yourself and how to aid a shock victim. If you don't want to become a victim yourself, find out if the person you're helping is in contact with an energized circuit and shut it down before you approach. If you're not sure, assume that touching the victim could shock you. First, make every attempt to turn off the electricity. If you have to move someone off a live circuit, use something non-conductive, like a dry wooden chair, board, pole, plastic pipe, or rope. Be careful using wood exposed to humidity. Humidity fills wood with water, making it conductive. Once you have safely separated the victim from the energized circuit, call or send for emergency medical help. After protecting the victim from potential spinal cord injury, apply the 4-letter assessment technique. A, is the airway open? B, is the victim breathing? C, does the victim have a pulse? H, is the victim bleeding? Your ability to safely take actions to help a victim of electrical injury, combined with your ability to apply the right first aid, can mediate the strike of the snake. You've seen electrical safety in 3 levels of protection: engineering controls, safe work practices, including training, and personal protective equipment. Let's add a 4th level in the safety chain: you. Unless you use the proper procedures, engineering controls, and PPE, you are not only risking your own life, but the lives of co-workers as well. Think of electrical safety as a square. Each side represents something critical for electrical safety: engineering controls, safe work practices, PPE, and you. Remove any side, and electrical safety is also removed. Remember, your employer provides 3 sides of this square, but you are responsible to make it work. Electricity strikes the complacent and the unwary with unseen, fast, and deadly results. In every task, remember, if you are unsure about safe procedures or conditions, don't do that job until you are sure. Remember, one mistake may be one mistake too many. Work smart and beware the bite.